それでは Day2 始めてまいりましょう。日立システムズの本川さんより本日の基調講演をご紹介いただきます。本川さん、よろしくお願いいたします。
日立システムズの本川と申します。
My name is Motokawa from Hitachi Systems.
今日は素晴らしいキーノートの講演者をご紹介します。
Today I have the pleasure to introduce a great keynote.
彼はインシデントレスポンスの第一人者で、コミュニティでも大活躍をしています。
He's very well known in the response world and in the community.
以前はブラックハットジャパンでトレーニングを行っていただきました。
He previously also has held some trainings at Black Hat Japan.
ラス・ロジャースさんです。
Russ Rogers.
よろしくお願いいたします。
Russ Rogers, please.
Good afternoon. My name is Russ Rogers. I'm a forensics expert and incident response team lead from Microsoft Corporation. And today I'd like to speak to you a little bit about practical incident response. So who am I? As I said before, I work for Microsoft, and I'm excited and honored to be speaking at Code Blue this year. My focus is mainly forensics on Windows and on Linux operating system. I'm a researcher, a developer, as well as an author, a professor, and a hacker. If you've been to Black Hat and DEF CON, there's a good chance that you've seen me in the past. So let's start and talk a little bit about the incident response timeline. How do these engagements typically flow? So we start with the initial compromise of a customer's network system. So the initial compromise may be weeks, months, or years old by the time it's discovered. And in many cases, we'll find multiple actors on the same network with incidents that span 8 to 12 months that have happened years in the past as well. We can still find indicators of the malware and the tools that they used when they were in the network doing some of the work that we'll discuss today. After we've detected the compromise, we kind of move into the response phase, and you can conduct the response on your own, or you can hire an outside contractor to do the work for you. The response time depends a lot on your selected mode of operation, right? So there are quicker response activities that normally take 1 to 3 weeks max. Slower response activities can take several months, and we want to answer the key questions here about who, what, how, why, and when. Once we've kind of got a handle on all those questions and we have answers that we can provide to those, we move into a tactical recovery. And the tactical recovery is where we plan and execute the eviction of the attacker from the network. We use the output from the response phase to plan both the tactical recovery and the phase that comes after tactical recovery. And what we do during the response is to identify C2 connections. We identify compromised user accounts, credentials, compromised systems, whether those be workstations or servers, to identify any compromised cloud assets that we may be using. And we use that information to evict the hacker and lock down the network as best we can and get the business operational in a secure environment. Once that's done, we move over to the strategic recovery. And the strategic recovery is a long-term process where the organization focuses on strategic plans to improve the security posture of the organization and to lock down some of the systemic issues that the organization has when it comes to security. And this includes auditing and logging, incident response, incident detection, the monitoring, both on the network and on the endpoints of the network. So the questions. These are the questions we're interested in answering as we go through this process. First, how did the attackers get in? What was that initial vector that allowed them to gain a foothold with credentials and on a system? And why didn't we detect that compromise when it initially occurred? When did they get in? How long have they been in the network? This is important to understand because it helps us determine how far they could have gotten in the network in a period of time. We'll give you as much information we can so that you can make those determinations on your own. Once we respond to the incident, we get on site, we want to understand what the actors are doing right now. What are their current activities? What systems are they in? What activities are they performing? What other accounts do they have? What data have they accessed? Have they exfiltrated any of our critical information, right? What malware did the actors use? And now it's important to delineate or differentiate between malware and binaries that exist on a network for system administrators that may allow attackers to do what they need to on the network. And we call those living off the land binaries or low bin. And then finally, we want to understand if the attackers have actually taken anything. Have they gotten any intellectual property? Have they stolen any customer data? That's important for you to understand as you respond to these things. Let's talk a little bit about the types of response. The first type I'm going to talk about is the traditional incident response that we're used to talking about. And this is the digital forensics incident response, or DFIR. This is a slow process. It requires deep forensics on dead box images that have been captured off of workstations or servers, right? So we'll make a hard disk image and we'll conduct all of our work on a copy of that image so that we don't destroy any of the original artifacts that exist in that image. The reason we did this is it created a chain of custody, and it allowed us in the beginning to not only identify the attackers, but to potentially seek legal action against those attackers. Do we want to put somebody in jail for attacking our network? It's understandable that this process, because of the way it functions, it will be more expensive. It will be more time intensive, and it will cost more money to conduct because it takes longer. But this process allows you to understand all of the details. It's a comprehensive view of what happened. The second type of incident response is the one that we typically prefer within Microsoft for our customers. This is an incident response with a forensics overlay that does not require the process to image every single workstation or server. We conduct this process typically in 2 to 3 weeks maximum, and we focus primarily on the key indicators of compromise. Again, those accounts, the systems, the malware that was used, any of the binaries that exist, and the command and control, right? We call all these things together kind of the tools, tactics, and processes that are used by the attackers, or the TTPs. This is often less expensive because it doesn't take as many people, it doesn't take as long to complete, and it should give us all of the information that we need to move into the tactical response and lock the network down and get the actors evicted from the network. Again, the goal here is to identify those key indicators as quickly as possible and to lock the network down again so that your business can get back to operating in a secure environment. So which process is best for you? So this comes down to a risk-based decision by your senior leadership. You're going to have to make a decision about whether we want to spend a lot of time pursuing this incident. Do we want to know absolutely everything? Or are we good enough understanding the important aspects of our network? Mostly how did they get in? What did they do while they were there? What tools did they use? What accounts are compromised? What machines are at risk? And we can take all that information and we can combine it with any configuration issues on servers or services on the network, and we can lock the network down and evict the actor. Again, it really depends on what your end goal here is. So recognizing a compromise. This is really important. to recognize what's different in a network, we must first understand what is normal in the network. So we're going to talk a little bit about normalizing your network. We want to create a baseline of network traffic, system configurations, times that users access applications or the network, where they access the network from, items like that. So the goal here is to prepare now to be more effective later. If we spend the time up front before a compromise to normalize and baseline the network and collect that information, then when a compromise occurs, we are better suited to respond to that, and will be more capable of identifying those things that are unique on the network. And we want auditing and monitoring data. The availability of historical data from systems and applications and network devices can help us identify how and when the attack began. If we don't have this historical data when we start the incident response process, we're going to find it very difficult to complete the story of what happened. And that includes that 0 day, that patient zero, if you were, this is the user account on this machine that was sent a phishing attack with this exploit that gave the attackers a way to get into the network. And so if we ensure the auditing and the monitoring is being conducted and that data is being saved for a reasonable period of time, it gives us a step forward to make our incident response activities more successful. So what's normal? Let's talk about what we're looking for. So we want to understand some of these key points. How are the user workstations configured? And are they all built exactly the same? If the workstations are built all the same and the users have access to all the same approved software and they're not allowed to install their own software applications, then when we find unique pieces of software that are not on the approved list, those things stand out. And the same is true with server configurations. Do we have a gold image, a server image of, say, the Windows Server operating system that is normalized, things we know should be on there, configurations that we know are secure, and what happens on those servers as they're operating, right? We want to understand what's normal. Allowed applications, do we have application whitelisting? Again, this goes back to, we have a list of applications we know that our users need to conduct their business, and those are the ones that we allow on the network. Anything outside of that range gets reviewed and approved on a periodic basis by a configuration control board. What are the normal business hours? Where do normal connections come from? From external addresses, right? So if we have users working from home during this pandemic and they work from specific regions, have we identified the IP addresses or the networks that those connections are coming from? And what times a day do they normally log in? We need to identify authorized privileged accounts like backup operators, domain administrator, enterprise administrator, things like that. And this applies to cloud accounts as well. Things like global administrator or account administrators in O365 or in Azure Active Directory. We also want to identify all the existing trust relationships. Do we have partners? Do we have subsidiary organizations of the same company that we work with? Are there two-way trusts, or is it a one-way trust? And is there SID filtering? Is there a mechanism to ensure that a domain administrator on a partner network is unable to come into our network as a domain administrator as well? We've seen many cases where compromises have actually moved into other organizations via these trust models. We also want to identify where the security testing systems are. These are the systems that run vulnerability scans, and they'll have applications like Nessus or Qualys. We want to understand where those exist. We want to understand what accounts have access to those and what the schedule looks like for security testing on the network, because some of those tools could be used by attackers during a compromise to baseline the network for their own needs. And then finally, to truly normalize our data or our information about the network, we want to understand what the critical systems are. The critical systems are those servers or data handling services that hold the critical information to our operations. So the data that is most important to ensuring we can conduct our business and meet our obligations as a business, those are the ones that we want to identify. We want to know what they do, what data they have, where they sit on the network, and who's allowed to access those. So let's talk about 3 rules for successful incident response. So first, let's look at data from lots of standardized computers. If we take all of the systems on the network, workstations and servers, and we collect a whole bunch of information from each of those, and we put those all together into a database, then we have the ability to find out which pieces of malware or which actions on these systems are most unique across the entire environment, right? And this is most useful when we have already normalized the network. We already know what looks normal because we've already defined that and put things in place to try and contain that. The second one is a little bit more difficult. We haven't normalized the network in number 2, but we still collect data from large numbers of computers. So we get as much data from as many systems on the network as we can. It's a little bit more difficult to define what's unique, to find those interesting services or the interesting binaries on the network, but it can still be done. Lastly, if we were to gather data from a single computer one at a time, it is much more difficult to determine what's unique across the environment because we're only looking at data from a single system, right? And so this comes back down to that traditional DFIR, that digital forensics incident response, the long process where we're creating disk images from a bunch of systems and we're looking at those one at a time. And that's actually the most difficult way to identify what's unique on the network and really identify those indicators of compromise that we're interested in. So we do all this so that we can hunt what is unique. We want to look for unusual login locations, unusual login times, unusual binaries or data files or services, scheduled tasks, things like that. We want to look for administrative tools that may be used elsewhere on the network but exist in unique locations. For example, we've seen C:perf logs be used repeatedly by attacks because it's accessible, and they'll copy the tools that they need into that directory and run them from that location because there are fewer restrictions on accounts that can run from there. We want to look for unrecognized user accounts. This refers to both normal users as well as administrative users. We want to understand if anything has been created, and we want to use the security tools that are already available for you. If you've taken your time before a compromise to ensure you have the proper EDRs, the proper auditing, the proper monitoring in place, then we should be able to locate these things that are most unique in the environment. So let's talk a little bit about persistence. Persistence means that an attacker that gets into a network has the ability to come back into that network whenever they want. And that means they have to create a process that can survive when a system is rebooted or when it is restarted, right? And so this is typically a scheduled task or a service or a registry key or something along those lines. And that applies to both Windows and to Linux and BSD style systems, right? It may also refer to a reverse tunnel. So when a server is compromised, an attacker can set up a means for the server to call back out to a specific C2 channel and make that reverse tunnel for the attackers. And we see this quite a bit as we do the incident response. The methods of persistence, this is the identifier, this is how we define this. Those persistent mechanisms must restart when the system restarts. Otherwise, they don't do the attackers any good. But this allows us a starting point for what to look for when we do the investigation. So we'll start by looking at the startup scripts or the scheduled tasks, the cron jobs, the services, the kernel modules, all those things that get loaded every time a system starts over. So let's talk a little bit about attacker tools. Attackers tend not to put their tools on every single system. So when an attacker gets into a network, they want to limit the number of places they put the tools, because the more places we put malware or tools, the better chance we have of getting detected or getting caught. So we want to limit our exposure as the attacker to being detected. To use the same directories across systems. Now, this isn't across compromises. This is within the context of a single compromise. Attackers will put their tools in the same directories on the systems within a single organization. So if I compromise 4 servers, I will tend to put all of my tools in the same directories on those 4 servers. That makes it easier to keep up with. And that's also a location that we know those tools will work. Tools can be commodity, which we define as things that you can just download off the internet. A tool that somebody else has written, and this could be Mimikatz, Metasploit, Empire, PowerShell, things like that. But there are also targeted tools, things that were written specifically to target your organization and allow attackers to work within your environment. And then finally, we have the living off the land binaries, or the lull bins, which are just common tools such as sysinternals. The big exception to all this is ransomware, and there's a large quantity of systems that are infected with ransomware via scheduled task, and these can be manually triggered, or these can be triggered via long-term scheduled tasks services. So security tools, we'll touch on this briefly, things that will help you. Antivirus, as long as the antivirus signatures are up to date, you have the ability to detect on things that are already known. But antivirus and our next category, endpoint detection, the EDR applications, can be disabled by attackers with the appropriate privileges. EDR applications really give you insight into what's happening on a single host. And once you consolidate all those into a single dashboard, you can get an idea of what's happening across the network at any one point in time. Again, what if the malware is unknown? What if this is targeted directly to your organization? This is important to note because this goes back to identifying those services or binaries that are truly unique within your environment. If we want to find malware that was written specifically for your organization, we have to step back and look for those things that are truly unique across your network. Hunting persistence, we touched on this a little bit a few minutes ago. The services, the scheduled tasks, the kernel modules, the cron jobs, things like that. Those are what we're looking for. We want to understand how the attackers continue to get back into the network. In the end, something somewhere on some server is allowing the attacker to get back. It's either a service that's listening for a connection, or it's making that reverse tunnel request back out to the internet to a known C2 channel to receive commands from an attacker. So if you normalize your data, if you normalize your network, if you understand what the configuration looks like across your entire organization, then when a compromise is detected, it's going to be that much easier for you to react and to be successful as you do your investigations. And the goal here is not to ensure that you never get compromised again, right? Because attackers are constantly evolving and escalating the way they do their work. What we want to do is detect these compromises more quickly in time, and we want to limit the exposure or the impact of a compromise. And we want to understand what accounts and systems were compromised and what those C2 channels were more quickly. If you don't normalize, it's going to be very difficult to find those attackers, to find what's interesting, to find what's unique on the network. And so it's very important to address that in the beginning and try and get that taken care of so you're better able to respond when an incident does happen on your network. Thank you. I appreciate being here today. Again, my name is Russ Rogers. I'm from Microsoft, and I'm looking forward to your questions.
はい、基調講演終了となりました。この基調講演の、冒頭の部分、またオープニングの部分も一部だったかと思いますけれども、音声トラブルで、声が聞こえていなかった方がいらっしゃるかと思います。機材トラブル、でのご迷惑をおかけいたしました。大変申し訳ございません。この後講師、この基調講演につきましては、録画されたものをできるだけ早く、イベントハブ内にアップロードしていきたいと思っておりますので、お待ちいただければと思います。また講師のラスさんにはこの後Ask the Speakerの場を設けておりますので、そちらで直接ご質問いただける機会がございます。ぜひそちらにご参加ください。Ask the Speakerに関しましては、タイムテーブルの基調講演の箇所をクリックしていただきますと、一番下に詳細 URL となってリンクが貼ってあります。そちらからお入りいただけます。よろしくお願いいたします。
Hey everyone, so we had some audio issues on the main channel, so we're going to be uploading the video up to Event Hub as soon as possible, but for right now, if you had any questions for what audio you did catch, we will have ask the speaker session right after this, so you can ask the speaker a question directly, and you can find the link at the bottom of the session overview page.
ではこれから休憩を挟みまして、次のセッション、タン・キアン・ソンさんから10万ドル相当のビットコインウォレットを盗んだのは誰か、新しい詐欺的な餌で全員捕まえようというセッションをご紹介いただきます。Next session will start soon. Thank you.
あらゆるものをデジタル化し、先端技術を駆使して新たなビジネスモデルの創出や生活の質の向上を図るデジタライゼーション。日立システムズは加速するその潮流の中で、多彩な人材と先進の情報技術を組み合わせた独自のサービスにより、お客様に驚きと感動をお届けします。